I think we got to here yesterday. We just finished going through domain.
Sure. Yes.
Yes. So the next piece we need to look at is composition. So what do you remember about composition?
You just plug it in, don't you?
Yeah.
Snatch.
When you plug one into the other, so here are my two functions. When I ask for f composed with g, another way of saying that, that's like saying f of g of x. So you start on the inside. What's g of x?
X minus 3.
And if I plug that into f, we have x minus 3
Square.
squared, which if you multiply that out, you get x squared minus 6x plus 9. Are you guys okay with the fact that I did not show any work right there on the distributing? Just spoiling that. So the other direction, g composed with f, is g of f of x. F of x is x squared, so if I put that into g, we get
X squared minus 3.
Let's try some of these. The next example, it's a composition, but I gave it to you in the table. So when I say f of g of 1, start on the inside. What is g of 1?
6.
Right, it's like saying when x equals 1, g is 6. So then f of 6 is 5. You guys try the rest.
Whoa, whoa, whoa.
Is 3. So then you have g of 3, which is 2. C, f of 1. So starting on the inside, f of 1 is 3. So then we have f of 3, which is 4. D, g of 1. So g of 1 is 6. So g of 6 is 3. E. So this just means g of f of 3. So when x is 3, f is 4, and then g of 4 is 1. F of g of 6. So g of 6 is 3, and f of 3 is 4. Are we okay with this? Let's do a few more compositions. Why don't you guys give these a shot? Let's see. So the first one, g of f of x. So f was 3x minus 1. You have to plug that into g. Okay, so if you square that, you get 9x squared minus 6x plus 1. Distribute by negative 4. Negative 18x squared plus 12x minus 2. So we get negative 18x squared plus 7. Do you guys agree? Good. B, f of g of x. G is the square root of x plus 6. So if we plug that into f, square root of x plus 6 squared plus 4. So you get x plus 10. All right, Are we good with the compositions like that? One thing we haven't touched on yet is the domain of the composition. So back in pre-calculus algebra or college algebra, I showed you some different strategies for finding these domains. And really, what we like to do is, did you do it? You're welcome. We actually worked out the composition first to find the domain. So this is f composed with f. So f is the square root of x. If I plug that in, then we get the square root of the square root of x. Okay, another way to write that would be a fourth root of x. Either way is fine. For domain purposes, you have to look two places. The inside part, because the first thing I'm going to do is plug a number in there. If I'm going to do the square root, what kind of number did that have to be? Has to be positive, right? So I know right now that number has to be greater than or equal to 0. And then we also looked at the final answer. Okay, if I'm going to do 2 square roots or a fourth root, what kind of number does this have to be? Has to be positive as well. So that one has to be greater than or equal to 0. And you put the two together. So both of these were the same, so my domain is just everything 0 and larger. B, G composed with F. So F is the square root of X, and then plugging that into G, so that's the square root of 2 minus the square root of X. So for my domain, we have to look two places. The original right here, what did that tell me? And we also need to look down here. So whatever's under that radical had to be greater than or equal to 0, right? What would you do there?
Subtract over 2.
Okay. And then?
That would do 1
Oops, not 0. What did I do? So that tells me x has to be less than or equal to 4. So it had to be bigger than 0 but smaller than 4.
Why is it so many? Like, why'd you subtract over the square root of x?
Oh, I divided by -1, which flips the inequality.
I know.
So first I subtracted my 2.
Oh, subtracted 2. Okay.
So this one, you can only plug in numbers between 0 and 4. If I put in like a 9 to start with, well, I would get the square root of 9, which is 3, but then could you do the square root of 2 minus 3? No, it would be imaginary. So that's where this domain came from. Okay. Couple examples left and then we're done for today. I'll give you guys time to work. All right, we can do more than one composition. Okay, all the ones we've done so far is just F composed with G, but we could put more together. So if I asked for F composed with G composed with H. You just start on the inside. So what is H of X? All right, so I start by putting in that X plus 2. Now I need to put x plus 3 into g. So what would that give me? And then I have to put that into f. So we get x plus 3 to the 10th over x plus 3 to the 10th plus 1. And you can leave it like that. You don't have to go any further. So far, so good? So the last example that we're going to do today is working backwards. I'm going to give you the composition and we're going to figure out what the original functions could have been. Sometimes there are multiple correct answers on these. Okay. So I know my function is found by doing f composed with g. So I have to figure out what f of x and g of x were to start with. Do you guys remember doing these last year? We have done them. G was the inside. So what's the inside here? Or think of it, if I'm going to plug in a number for x, what am I going to do first? The parentheses. So I could say my g of x is 3x minus 4. Okay, so when you do a composition, what you're doing is replacing x with something. So if I'm undoing my composition, it means when I take this out, I put an x back in its spot. So if I replace that with an x, it's just 4 over x. Why don't you guys try B and C?
Yeah, she will. I think she is.
She didn't miss all tracks this time.
All right, so on B, g of x. G is the second one, so it's the inside. So what do you guys put? So if you replace that with an x, that means f is -2, absolute value of x. All right, C, 3 of them.
Yeah, I did. I had no idea.
Oh.
But
All right, what's the first thing?
X plus 9.
All right, so h of x is x plus 9.
that was easy.
All right, so if I take that out, I have cosine squared x. Remember, that means cosine of x squared. So, if you plugged in an x, what would you do next?
Square it.
You would have to do the cosine first, wouldn't you? Do the inside of the parentheses. So my g of x is the cosine of x. Then if I replace that with an x, what am I left with?
X squared. A lot of X squared.
A lot of x's.
That makes a lot of sense.
So, homework. You guys got a handout? Yes. Did you just tell me no?
No, I said none.
Oh, you just said no. Felt like I was talking to my 1-year-old.